Hey, and I'll try to keep this as quick as possible, but it's going to be difficult. So he's using two methods here. What he's doing here is he's finding the y-intercept, of course, by making x 0. So you get plus 7. So the coordinate is 0, 7. Here, he's finding the x-intercepts by factoring. And he determines that the x-intercepts, because it's minus 7 here and minus 1 here, are 7, 0 and 1, 0. Here, what's interesting is he's finding the axis of symmetry. As I tried to, I think, point out in one of our sessions, when you have determined the x-intercepts, the axis of symmetry is halfway between those points. So if this is the first x-intercept and this is the second x-intercept, we can see that the distance between 1 and 7, if this is 1 and this is 7, is 6. So let's say that's 2, 3, 4, 5, 6. We can see that it's 1, 2, 3, 4, 5, 6 apart. And the axis of symmetry will always be halfway between those two. Well, the halfway point between 6 apart is 3, 1, 2, 3, 4. The method that he uses is very common as well. He simply adds this, the distance between any 2 points is when you add them together and divide it by 2. So he's added the 2 points, 7 and 1, and divided by 2 and determined that, sorry, not the distance, rather the midpoint, the point that's in between the two is always when you add them and divide by 2. This is a handy technique to remember for future as well. I won't get into why, but when you add them together and divide by 2, you discover that the point is 4. Even though they're 3 apart, you had to add 3 to this 1 to get to the 4. Once he has that 4, the axis of symmetry will also always fall on the vertex. Therefore, he knows that the value of the vertex, x for the vertex, is 4. So he simply plugs the 4 back into this equation, or this equation. In this case, he does the original equation up here. And once you put 4 into there, 4 squared is 16, minus 8 times 4 is minus 32, plus 7. It comes out to minus 9. Thus, he has figured out the vertex without completing the square. It is, of course, a minimum because it's done that. So that he's discovered it's down here. However, completing the square, as you point out in your question, or in the question you sent me, is a valid method as well. He is not doing that in this case. However, if you notice here, there's a 1 here. So we would just half the minus 8 squared plus 7. Keep in mind, however, that, but once we minus the, we have to put the plus 7 over here. Once we minus the 4, we now have to subtract whatever the square of minus 4 is, which is minus 16. Minus 16 plus 7 is minus 9. So you still get the right answer. And this is always the opposite. It's always 4, minus 9. Just as these are always the opposite. It's 7, 0, not minus 7, 0. And minus 1, 1, 0, not minus 1, 0. That's because it takes a positive 7 of x to make this bracket 0. And it takes a positive 1 of x to make this bracket 0. Just as over here, it takes a positive 4 to make this bracket 0, which would leave this minus 9. So that's when we plug in 4 into this formula, which is now the completed square, x minus 4 squared minus 9. If we put a 4 into this formula, this bracket becomes 0. 0 squared is 0, and we're left with minus 9, which is the value right up here. In other words, when x is 4, y becomes minus 9 because all of this is equal to y. That's a fast explanation, but he's using two methods. He's using the axis of symmetry method here to find the x value. X is equal to 4 is the axis of symmetry, but it's also the value of the x in the vertex because the axis of symmetry always goes through the vertex. He's then plugging the 4 into the equation to get the y value of the axis of symmetry. So he didn't even have to complete the square.